Frustration that I feel also when you have this BIM specification in your hand that is too generic, ambiguous, and clear. So basically in this presentation I will be talking about BIM specification. I will not be talking about Revit modeling. We go beyond Revit modeling. This is the main problem of the industry right now. I'm from Singapore and we are quite advanced in terms of BIM adoption. We implemented BIM in year 2011, and then I found out that even though we have a good software, good implementation on hand, we still have this problem. And then the main cause of this problem, specification. So in this presentation, I will tell you how to create a BIM specification, how to structure a really good BIM specification. So the key learning objectives of this presentation is to understand the structure of a BIM specification, specifically the fundamental concept of a BIM specification. And then the second one, to understand the required strategies and information management practices that should be incorporated into BIM specification. And of course, after this presentation, we will have some level of confidence on how to write a clear and consistent specification. So allow me to introduce myself. I am Rexter Retana. I am the BIM manager for RSP Architects, Planners, and Engineers in Singapore. And we are a multidisciplinary consulting firm across Asia. We have one branch here in Dubai as well. I have here our director, Mr. Bano. And then I was quite privileged also to be part of the BCA BIM work group. This is the main core work group who creates the national BIM standards in Singapore. So it was quite a privilege to be part of it. And I also co-founded the BIM Exchange user group. Now this user group is a bit different from other Revit user group. This user group specifically talk about procedures, workflow, and BIM management in general. And then for those of you who are social media enthusiasts here, we can connect through LinkedIn, and you can follow me through Twitter as well. So every time I give presentation, I always start my presentation with a story. So please allow me to give you a good story. So once upon a time, in a village called IFC, there was once a great ruler who wanted to build a tree ceiling for his people. So he summoned the best architect of his time. He talked to the architect, he relayed his visions and ideals to the architect, and in turn, this architect translated these visions and ideals into a concept design. Thereafter, the architect gathered his best people. That includes the designer, who have his own version of the design, the QS, who will estimate the project cost, and of course, the specialist who will add special feature to the project. And then again, there is the structural engineer who will ensure the overall stability and integrity of the project. And of course, there is the builder, the contractor. But there is a problem with this project. There was quite a huge delay for this project. And when the project came to completion, the owner was quite shocked about the cost incurred for this project. What he truly wanted is only a simple rubber wheel tree swing. Now let me ask this question. What could have possibly caused the increase in cost for this project? Any idea? Lack of communication, correct? Any idea? Guys there, any idea? It is basically the undocumented requirements. Now most of the time, project delays, cost overrun are caused by these undocumented requirements. And it is quite the same with all BIM projects as well. Therefore, it is very important that the client should establish a proper communication strategy to relay his needs and requirements directly to the supply chain. And this should be in the form of what we call a specification. A specification builds the foundation of a good, accurate communication strategy from the employer to the supply chain. So for those of you who don't know what is a specification, allow me to give you a brief introduction of what is a specification. According to the Construction Specification Institute, a specification is defined as a documented set of requirements to be satisfied by either a material, a product, a design, or in our case, as a consulting firm, a services. Now, these specifications should contain at least the two core fundamental requirements. Basically, the first one is what we call qualitative requirements. This is the minimum quality criteria set by the client. And of course, the second one is what we call administrative procedures. These are the workflows and processes put in place in order to achieve those quality requirements. Now, this said, in order for a specification to effectively communicate the client's needs and requirements to the supply chain, the specification should contain the what I called 4 C's of effective communication. It should be clear, concise, correct, and complete. Now, allow me to give you example of this one, excerpt from a real project requirement. And I know that this topic is quite a boring topic, so I don't give you too much details on it. So when we say clear, it is actually the use of proper grammar and simple sentence construction. So this requirement here is from a real project requirement, an excerpt from a real project requirement. The problem with this requirement, although it mentioned here the use of omni-class classification system, do I know in Singapore, do you use omni-class or uni-class classification system? Or do you know what is omni-class and uni-class? No? Okay. Okay, I'll tell you later what is omni-class and uni-class. So basically, omni-class and uni-class is a classification system. So in this requirement, the client required the use of omni-class classification system. But it is unclear as to what is the relationship of this omni-class classification system to the rest of the requirement. So to give you an idea, the above one is actually a real project requirement, an excerpt of the real project requirement. The second one is what I think it should be written in order to relay the good message to the supplier or the supply chain. So basically, if you want to incorporate omni-class classification system, he should mention that it should be associated to relevant asset, and in terms of asset, there is a COBie data fields. Are you familiar with COBie? COBie? Construction Operation Building Information Exchange. Okay. Second one is what we call concise. So when we say concise, a specification should eliminate unnecessary words, but of course not to the expense of clarity, completeness, and correctness. So this one again, excerpt from a real project requirement. The problem with this one, the specification writer only express some facts, but there is no such requirement that needs to be fulfilled here. So from what I understand from this requirement, what he really requires is the inclusion of the minimum asset information that needs to be integrated to the building information model. So correct. So a specification should present information accurately and precisely. This is an excerpt also from real project requirement, and it is very, very common in Singapore. They use IFC file, the word IFC file. Would you agree with me that there's no such thing as IFC file? Would you agree with me? Do you know what is IFC file? Yeah? But would you agree with me that there's no such thing as IFC file? No? Okay, there is no such thing as IFC file, and by that I mean you cannot have all the schemas inside the IFC file. Meaning, these schemas is actually the building data sets. If you are a structural engineer, we're doing some project together, what you actually need from IFC is only the IFC structural model view definition. So in IFC, there is actually 4 to 5 model view definitions. So this is, an IFC is actually an aggregate of the model view definition. So first one, we have the IFC FM handover model view definition. Second one, we have IFC structural model view definition. Third one, we have what is commonly when we do interoperability and collaboration together, IFC 2x3 coordination view, and the latest one is 2.0. And then right now, currently, there is an IFC 4, which is actually correlated to the COBie data. But the problem with the IFC 4, it is still not consumed or not usable by any other BIM authoring tool. And then currently, the Building Smart, there is a new one, still in the planning stage, what we call IFC 5. So in this case, what the client truly need is only the IFC 2x3 coordination view 2.0. See the difference here? It's complete. The fourth one is complete. A specification should not leave out important information. Again, an excerpt from a real project requirement, although it is very good here that the client mentioned to use or to deliver, the contractor should deliver a single consolidated COBie information in terms of a SAML format. But the problem is, the client failed to indicate which type of COBie template you're going to use. Do you know that there's 2 COBie templates out there? Do you know? For those who are BIM managers, BIM directors here working on a project, do you know what is COBie? And do you know that there's 2 variations of COBie template out there? There is a US COBie 2.4 template, and there is a UK COBie 2.4 template. US uses Omniclass classification system. UK uses Uniclass 2.0 classification system. So the difference between the two, there's actually not much difference, but the UK tends to have more requirements in terms of data fields. So that's why it is very important to indicate which type of COBie template you're going to use in order to set out correct expectation. So I know why I know that they are using US COBie 2.4 template here, because of the previous requirement, which is the Omniclass classification system that is directly associated to US COBie 2.4 template. And then as part, my role in RSP architects, planners, and engineers is basically a BIM manager. I handled projects. I handled architectural and structural projects, some iconic projects in Singapore. And then part of that, I also engage in the business development team who will try to understand some of the requests for proposal or RFPs or tender specification. So from that tender specification, in average, let's say in 1 month, I received 3 to 5 tender specs or 3 to 5 RFPs. From that RFP, I will go through each page by page, and I will try to select some of the BIM requirements there. And then from that BIM requirements, I will try to aggregate that one, and then I will say to our organization that this is the good strategy that should be in place in order to fulfill those requirements. So from that experience, I found out that there are 3 common issues in a BIM specification. This is true in Singapore and in the UK as well. I don't know about in Dubai. So first, it is generic. Second one, it is ambiguous. Third, it is unrealistic. So when we say generic, it is actually a single generic clause that is injected to the project specification that is devoid of details and justification. So for those of you who are familiar here with a project specification that is contractually bound, you have a project specification, let's say 200 pages, 300 pages, and there's only one slot there, one paragraph mentioned that you have to use building information modeling. But you don't know how to fulfill these requirements because there is no BIM deliverables explained or structured there. And there's also no phases or timeline when you should deliver those deliverables. And this came from a real project requirement. It mentioned here level 2 standard in line with BS 1192. I know that there is BIM level 2 in UK, but there's no level 2 that I've encountered. So actually, this one is wrongly phrased. So another one, yet I think this is the most funniest clause I've ever encountered in terms of BIM, when it comes to BIM specification. It states here that the contractor shall procure or use building information modeling. However, the writer of this specification have this inner passion and enthusiasm. He added what I called unnecessary or inappropriate phrase there. He mentioned that BIM is a powerful 3-dimensional computer modeling tool that could help the built environment and the rest of the world. Maybe a solution also for climate change, I guess. So this guy can be the ambassador to the United Nations when it comes to BIM. So the orange that I highlighted here, is basically inappropriate. You should not use this one because it doesn't mention or it doesn't require requirements that needs to be fulfilled by the supply chain. So ambiguous, again, this is very common in Singapore. It mentioned about interoperability, but how can you expect? He mentioned interoperability and then uses DWG. Do you know what is that DWG? Do you know? It's an AutoCAD. It's 2D. I use Revit, but then I give you DWG. Where's the sense there? So this one is wrongly phrased. Sorry. And then the second one, it mentioned here, level of detailing standard 3. I've been studying, I have experience also in both professional and academic practice when it comes to BIM management. I've been studying the most common international BIM standards, and I have never came across of the word level of detailing standard 3. So please, for those of you who will write a BIM specification, you have to make sure that those terminologies that you put there is actually what we use in the industry. Or, if you don't know, by all means, go to this website. This website is actually a BIM dictionary. So this, the first one, is created by Dr. Bilal Sukar, BIM Excellence. There's a BIM dictionary there. The second one is by Specified By. It's also a BIM dictionary that were derived from Brand Bryan's Architects BIM dictionaries. And I think this one is not only common to Singapore, but common to Dubai as well and the rest of the world. Basically, some of the BIM specification is unrealistic. When I say unrealistic, it is not achievable and inappropriate to reality. So basically, this one. Have you came across of a contract and specification that tell you your BIM model should be clash-free or zero clash upon or prior to submission? Have you encountered this one? Then go to the client and say, hey, fly kite. This is not achievable in the current technology, what we have right now. So that's why during tender stage, if we found out that there are some of the specification or requirements that is unclear, ambiguous, and inconsistent, automatically we raise a clarification to the client. But most of the time, the client don't know the answer. So we'll say, it's up to you. Requirements. Third one is what we call management standards. Fourth one is what we call commercial requirements. So basically, these are the four important categories inside the BIM specification. And we have to understand this one because a BIM specification is a contractual document. Revit in Singapore is not a contractual document. It is for the purpose of regulatory submission. The contractual document is actually the BIM specification, and at the end of the day, you have to comply on all the requirements written in the BIM specification. Whether you have a very good tools, whether you have a very good BIM manager, or whoever is that, if those requirements are unclear, inconsistent, and ambiguous, at the end of the day, you will experience problem. I have experienced this one in our current project today. And I tell you, it's not funny, and then there is some liabilities and legalities involved there. So let me explain the concept of these categories. So when we say general requirement, it's actually a brief overview and holistic summary of all the requirements. So say, for example, if you use BIM, you have to implement virtual design and construction through the use of integrated concurrent engineering, or PPP, process, policy, and procedures. Have you heard of VDC? Huh? No? Okay. Now you heard of VDC. VDC is actually a virtual design and construction. VDC is a principle above BIM. BIM, for me, I have two definitions of BIM. The first one is building information modeling, currently doing Revit. Second one is building information management, contractual terms, and then agreements when it comes to the use of building information modeling. And the second one is technical requirement. This is the category that expresses or establishes technical details. So this category involves what are the software that you're going to use. The data exchange format, geospatial reference, this is very, very important, and most of the time that is not indicated in the BIM specification or any other contractual documents. Level of detail and level of development. These two words are unconsciously interchanged, but fundamentally they are different. I will explain to you later what is the meaning, or the true meaning of level of detail and the true meaning of level of development, and what is the relationship of these two terminologies. The second one is model, second to last, model content and naming convention. So basically, these are the minimum section that should be integrated to a BIM specification. Management standards. So when we talk about management standards, this is basically the procedures and processes that determines or manage the delivery of information requirements. So it includes roles and responsibilities, BIM Execution Plan, Common Data Environment. Have you heard about the word Common Data Environment? Yes? Okay. Common Data Environment, Model Segregation Strategy, Quality Control, and Project Reviews. So for the management standards, these are the minimum specification that you have to put. And the last one, commercial requirement. When we say commercial requirement, it looks into the commercial consideration of the client. When we say commercial consideration, it is actually unique to the facility that you are building and unique to the client needs and requirements. So you have here asset information, you have here Kobe, you have here data drops. Have you heard of data drops? Guys, come on, have you heard about data drops? No, okay. Laser scanning, milestone and deliverables, electronic data exchange, risk, and IP, or intellectual property rights. So let's go first to technical requirements, and because of the time constraint, I don't think so I can go through one by one of each of these requirements. So let me just go through to the most, what you call this one, the most or the less anticipated, or the word that is interchangeably used but have different meaning by itself. So let me start with level of detail. So have you heard about level of detail? They mentioned level of detail 100, level of detail 200. It is actually incorrect. There is no such thing as level of detail 100, 200, 300, 400, 500, and so on and so forth. And my colleague says there is level of detail 3000. Have you encountered with that one? Okay. So when we talk about level of detail, there is a very good standards out there that mentions or that defines the true definition of level of detail. It is basically the BS 8541 Part 3, or commonly known as the Library Objects for Architecture, Engineering, and Construction. I love this document because it clearly defines the concept of level of detail. So according to this document, level of detail is actually the granularity, completeness, and accuracy of the virtual shape representation compared to the physical characteristics of the actual object. So you have the virtual shape and you have the actual object. Level of detail is actually the comparison between the actual and then the virtual. And of course, level of detail is not the same with level of development. So according to this document, level of detail, there's 3 types of level of detail. The first one is known as schematic level of detail, or we normally call this one grade 1. This is basically the object is characterized by key connections and connectivity. And in this level of detail, the object is represented by a 3D bounding box. So it's quite generic. The second one is what we call connecting level of detail, or grade 2. This is the object is characterized by a more detailed sufficient version of the grade 1 in order to recognize the object. And then the use case for this one is actually for object recognition and spatial allocation and class detection. So you don't need a very detailed model to perform class detection. And the last one, basically we use this one for visualization purposes, is what we call a visualization of level of detail, or grade 3. The object is characterized by a more detailed shape, insufficient to envisage its operation and use. And then the use case for this one is basically rendering and visualization of the usability of the equipment. So let me go through level of development, and later I will explain to you the relationship or the association between level of detail and level of development. Level of development, according to AIA G202 or the BIM Forum, level of development is basically a framework by which the project team can rely on the elements geometry. Remember the word elements geometry, and then the attached information. Remember the word attached information. So there's 2 aspects here: the elements geometry, and then the level of the attached information. It defines the framework of what we call level of development. Okay. So in layman's term, the level of development is basically a reliable output of both graphical and non-graphical. When we say graphical, it is the 3D component. When we say non-graphical, it is the information, right? So by this definition, we can actually derive the concept of level of development. So basically, it is the appropriate level of detail plus, or the combination of the level of information. These two are very basic. It defines the true concept of level of development. There's nothing else. Okay? So the question right now, as a client or as a contract administrator, how can you put level of development as part of your requirements inside the specification that it can be easily understood by the rest of the supply chain or even the contractor if you're procuring the services of the contractor? So basically what we do, we allocate a certain appendix in the contract or in BIM specification, and this appendix defines. We have the definition. Let's say, for example, LOD 100, we have a definition so that everybody can see through the definition, and then we will have a common understanding of what is LOD 100. And then, of course, we have associated project phase. Now, the LOD 100 should only be associated to conceptual design. And then we have the model content, and then we have level of detail, we have asset information. We will define the parameters that should be incorporated in this model at the stage of LOD 100 or concept design. And then if you use LOD 100, the model can be used for what? Then we will define the usage of the model. It is reliable only upon, for the outline, planning, permission, and project feasibility, and beyond that, it cannot be used. So we establish this common understanding so that actually by this style or way of presenting the definition of level of development, the contractor can really understand or will have a common understanding of what we clearly define as level of development. So let's say, for example, LOD 200, it is associated to preliminary design, model content. We have a separate appendix for the model content. So when I say architectural, what are those elements that should be incorporated to the architectural model? And mind you, in Singapore, they have I think for me, the Singapore only have a very good, accurate definition of the model content. It can be found in the Singapore BIM Standards version 2.0. You have to refer there. It's actually in Appendix E and Appendix B. Okay? And then we have level of detail. So for LOD 200, we define level of detail at minimum grade 1. And then asset information, this is basically the requirements, the information that is required by the client, unique to the facility that we are building. And then, of course, at LOD 200, model can be relied for planning approval, tender documentation. And then 300 is the same, 400 is the same, 500 is the same. So we have clearly defined the definition of level of development. Now you will ask me, hey, Rexter, how can we put this one into real practice? Can we put this one, or this is only a document? Yes, of course, we can put this one. Okay, let's have in mind level of development is actually level of detail plus level information. When I say level of development, it is not the same with level of detail. It is actually level of detail plus the combination of the appropriate information. So, okay, as an example, let's take a look. Let's take this ceiling-mounted projector as an example. How this object or element progress us through the project phases when you apply the concept of level of development. So let's say, for example, at the concept design, the ceiling-mounted projector is represented in terms of level of detail 2D. Like AutoCAD, you have 2D details. And then you have the basic information like name, type, classification. This classification is actually the OmniClass classification system, and then the location. So for the concept design, we have 2D representation. If you are a contractor, you pass to me a drawing or let's say a model, and for the ceiling-mounted projector, and you pass to me a 2D AutoCAD 2D representation, it's okay with me because you actually fulfill the requirement at LOD 100. So when we go through LOD 200, you now begin to see that the level of detail of this ceiling-mounted projector begin to have shape, volume, right? But still it is unrecognizable because at level of 200, still at grade 1. So again, as you can see, the level of information, there is an added level of information there. So when we go to LOD 300, the object right now becomes to be recognizable. You can see that it's actually a ceiling-mounted projector. But the interfaces between the ceiling-mounted projector and the connecting rod is still not clear, right? And then at level of development 300, you have those information. This is the minimum information that we require from the contractor. If you don't follow this information, then you are, if you don't fulfill this information, you are actually non-compliant, and I have to reject the model you've passed to me as the overall project BIM manager. So when you go to LOD 400, you begin now to see that there is a correlation between the ceiling-mounted projector and the rod. So it defines the interfaces between two elements here. And then, of course, there's so many level of information. Now, this level of information here is actually a non-exhausted list. This is basically defined by the client or the facility that you are going to use. And most of the time, the client don't know how to start to give the minimum set criteria when it comes to level of information. There is a document out there called the Kobe Guide. It is a very good document because it defines all the relevant information associated to a certain asset. And then, of course, level of 500, you have this one here. And now this is very, very important. This one. Warranty information, warranty description. This is very, very important. If you cannot attach this one into the model, then you have to submit the what we called Kobe spreadsheet. Okay, when we talk about management standards, because of the time constraint, I will talk about BIM Execution Plan and Common Data Environment. Do you know that there's two variations of BIM Execution Plan? Do you know? Have you heard of the two variations of a BIM Execution Plan? Or you only heard a single generic BEP? All right? So for us, in our practice, let me talk about BIM execution plan first, or the BEP. We have two variations of the BEP. These are the pre-contract BEP and the post-contract BEP. The pre-contract BEP is what we normally required for the bidder or from the contractor to submit to us in order for us to assess the BIM capability and competence of the contractor. And there is no such document that can assess that, only the pre-contract BEP. And I am quite amazed by some of the project requirements that they mentioned. In order for them to assess the BIM skills and capability of the contractor, they have to submit a one-page write-up. Then on the write-up, if you read the write-up, it says here, copy-paste from the internet, BIM is actually a building information modeling tool. And it's this one, if you use this one, it will help the creation of blah, 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 and also in the world. This is very, very common here. So in your BIM specification, you have to establish what are those requirements that needs to be incorporated into the pre-contract BEP. That's why your BIM specification will inform the total creation of the pre-contract BEP. And then when we awarded the contract to the contractor, then we will say, hey, contractor, because this pre-contract BEP is not so detailed, you have to update this one and then pass it back to us as a client representative, and then this will now be called a post-contract BEP. Now in this post-contract BEP, what we normally see, or as a BIM manager, what I normally check is actually the workflow and processes in terms of the creation and management of the required information. If as a contractor, he did comply with the management and practices to fulfill the requirements or the information requirements, then I have to chop this BEP, and then I can say, okay, you can start now your modeling. If the contractor haven't fulfilled the requirements of the post-contract BEP, I won't allow them to create the model, because at the end of the day, that model is useless because it doesn't comply to the requirements of the client. Now, let me give you, do you know the concept of information delivery cycle? So how does the BIM specification informs the creation of a BEP? So let's say, for example, there is one client who is planning now to build a healthcare facility. So as an architect, we will help the client create the BIM specification. And this, in this case, this is what we call the information, the employer's information requirement. And then from here, we will call for a tender. Then the contractor would tender, and then from the contractor we will say, hey, contractor, submit to us a pre-contract BEP so that we can verify your level of competence and capability in terms of building information modeling. And from there, we will award the project to a certain contractor, and then we will require him to update the post-contract BEP and pass it back to us. In UK, the post-contract BEP, the inclusion of post-contract BEP includes what we call Master Information Delivery Plan, MIDP. In Singapore, we call this one BIM Deliverables and Responsibility Matrix. So you have the architect, so let's say contractor, subcontractor, and then these are the models that he needs to submit at what is the project phase and when he will submit this one, something like that. And then the common data environment. Have you heard of the word common data environment? This is beginning to have traction in Singapore right now, especially during construction stage. So common data environment basically it is a collaborative platform. It is a central repository where all project information gathers together, and then as a contractor, subcontractor, you can push information inside common data environment, and you can also pull information inside the common data environment. This happens real time. So that's why in Singapore, most of the contract requires the establishment of common data environment. And now the question is, who owns the common data environment? Who? Huh? Yes, the client. Most of the time, it is owned by the contractor, but then the client should have overall control of the common data environment. So what are the common data environment we used? We have Aconex, we have Conjac, we have ProjectWise, we have 4 projects. And I would like to remind you, I'm not promoting this software, but these are the common software that we used in Singapore. And then commercial requirement. I mentioned earlier, the commercial requirement takes into consideration the commercial consideration of the client. So because of the time constraint, I will only be discussing what we call asset information, COBie, and data drops. So when we talk about asset information, basically, this is the information that you need to incorporate into the model. This information will be used by the facility managers and then operators. A good architect should have this in mind, should have a proper workflow and procedure to establish this one so that the required information requirements will be passed on smoothly from one project phase to the other, and then ultimate goal, give it to the facility managers and then the operators. Because currently, right now, what happened in a real project scenario, the contractor and then some of the suppliers or supply chain will give paper documents and then electronic documents to the facility manager, and then this poor facility manager will take 6 months to 1 year encoding those information manually, because there's no such thing. If you give them paper-based drawing or electronic drawing, automatically it will translate. But if you have a very good common data environment established at the beginning or onset of the project, then you will actually mitigate this risk. So let's say, for example, asset information. Let's say, for example, a fire protection system asset. So in a fire protection system, you have their pipes, something like that, sprinklers, right? So let's take a look at pump. Okay, what are the information that needs to be integrated to the pump? So as a contract administrator or as a client's representative, we require that the contractor should put this minimum information into the model. If he never follow this one, automatically the submission of the model will be rejected, right? So this information, again, in the BIM specification, in the contractual document, we allocate one appendix there called asset information requirement, and then as a contractor, you have to refer to, let's say, for example, a chiller. So in this chiller, these are all the information that I need to fulfill, and then you go one by one. So see this workflow is very, very clear as to what we require and to what you have to fulfill, right? COBie, construction, operation, building information exchange. This is also beginning to have traction in Singapore right now. Most of the big projects, healthcare projects, and then the publicly procured projects requires the delivery of COBie data. So when we say COBie, what we have in mind is an Excel spreadsheet, but COBie is beyond Excel spreadsheet. You have to see the information that is integrated to the COBie. Okay? So basically, COBie is a performance-based specification. So in layman's term, this performance-based specification refers to the equipment and spaces. There's two things only: equipment and spaces, nothing more. Okay? So why is that we are using COBie? There's many other platform there, or so there's many other solutions there that can actually extract information from the model and give it to the client or to the architect or to whoever needs the information. We actually use COBie because first, it is an open BIM concept. Second, COBie is actually a structured schema. When I say structured, there is a relationship from one parameter to the other parameter and to the other parameter. So if you have, let's say, pump, this pump belongs to this fire protection system, and this fire protection system or this pump belongs to these spaces. So you can see there is direct correlation between those information, right? And COBie is actually what we call the transporter of information. We require COBie because of the fact that COBie is actually a structured schema. In fact, did you know that COBie is a subset of IFC? Huh? No? Okay. COBie is a subset of IFC, specifically IFC4. So we require COBie because of the structured schema in order for us to review and validate those information that have been submitted by the contractor in terms of compliance, continuity, and completeness. Data drops. So you have already a strategy in place to get the information that you need as a client, and then you have actually a platform that will gather those information. Now the lacking piece is the delivery. How should I deliver this information? So this one is in the form of data drops. So in UK, there is a concept of data drops here through Employer's Information Requirement, or commonly known as the BIM Specification. So at CIC stage 1, during the preliminary design stage, you have all this information, facility, floor, zone, conduct. These information should be propagated and submitted by the contractor for us to validate and review and verify if those information have indeed complied with our information requirement. Now this concept here, this context here, we actually adopted this one in Singapore. So in Singapore, we have the delivery of COBie information is during preliminary design stage, detailed design stage, construction, and as-built. Okay, so we did this one because for us to have a gateway to check the information. Okay, because there's no use that you check the information during as-built. I don't think so that you can use that one, or you can even do that one. It requires much effort to do that. So general requirement, as I mentioned earlier, it should be a brief overview and holistic summary of all the information that you required from the supply chain. So this is the example sample clauses that should be integrated to the contract or the BIM specification. Let's say the use of building information modeling and proper synchronization management of information requirements. And then we have also the creation of project information model or asset information model. So project information model is actually a design model and construction model. Asset information model is basically what we call the as-built model. And then you have here, and then we also mentioned that if this is for an existing facility, you have to model those existing facility and the interfaces of those existing facility to the new facility. And then let me share you our experience in Singapore. We have implemented BIM started in year 2011, and most of the BIM specification there is unclear, inconsistent, and ambiguous. And you know what is the consequence of this one? Basically scope creep. Nothing more, nothing less. So from my experience, I found out that if you have a clear, inconsistent, and ambiguous BIM specification, you will have scope creep. And this scope creep came from two sources. The first one is basically from the demand side. We call this one as BIM scope creep. When I say demand side, this is from the client. Although the client doesn't specify correctly the structure or the information that he requires, but along as the project progresses, he will say, hey, other project uses computational fluid dynamics or CFD to exactly determine the wind flow or the airflow inside our building. Can you please use this one as well? And then it will require you cost, it will require you time, it will require you resources. This is basically the incremental expansion of project scope. I have published a paper. You can find this paper at the BIM space, BIMthinkspace.com. I have talked here about project boundaries and then the scope creep and what are the solutions that needs to be implemented by an organization in order to mitigate or to actually suppress this, what we call scope creep. The second one is gold plating. This is common, very, very common for those BIM managers or inexperienced BIM managers. And why is that so? Because normally right now, in reality, let's face this is the reality. You have a project, you have a contractual document. This contractual document will be read by the senior management. Those poor BIM managers who's doing the model and fulfilling those requirements doesn't understand or doesn't know what is the required in the contract. So we see there is a gap already here. So because as a BIM manager, I know Revit very well. I have to model this one so accurately. I have to put bolts. I have to put whatever is that modeled accurately. So in this case or in this scenario, you consume resources, you consume time, and basically those elements that you have modeled has no value to the project, right? So I started my presentation with the story. I will also end my presentation with the story, and this story has something to do with scope creep. So in Swedish in year 1626. Who amongst you here are born in year 1626? Huh? The Swedish government commissioned the shipbuilder to create what they called magnificent warship. This is called the Swedish Warship Vasa. So in 1626, this warship began its maiden voyage. And then this warship has been built by some of the skilled workers in their time. Now, because there is no problem with the cost there, basically this worker have implemented beyond what is required by the client or by the Swedish government. So basically, during design, the Swedish government asked for 32 cannons. But because there is no problem with the cost, this architect, this naval architect, added beyond 32 cannons. He added 64 cannons that is not considered in design. And then he added also some beautiful ornaments inside, which is composed of gold and titanium and platinum ornaments. So from there, when this Swedish warship began its voyage, after 1 mile of the first voyage, do you know what happened? Sunk. And then literally, scope creep or feature creep sunk the ship. Right? So, you have to take this into mind and into consideration. If you have a BIM projects, you have to only fulfill the requirements that is stated there. But of course, you can only fulfill those requirements if you have a clear, consistent, and ambiguous BIM specification. Thank you.